So I believe it's now 8:05, so we can begin. Thank you for those who have shared what they would like to learn. Also, there is one business. Okay, more coming in. Sawa, let me just give you 2 more minutes to share what you would like to learn by the end of the session. And then we begin. Okay, so these are a few things you have. Starting a business in this sector. For low power engineers, okay, what is the regulation process? Courses, job hunting, what are the jobs available? What is embedded systems, the minimum wage? Is VLSI important? Is Arduino good for job hunting? Yeah, so these are some of the things that we would like answered. Please continue providing them. Let me just copy this and share to the group so that you can continue giving your feedback on what you want to learn. So from here, let me introduce our speaker and then we get started. So I'll stop sharing my screen. And then let me share that to the group. Okay, so thank you for joining. I believe we can now begin. I'm sure we're all eager to hear from Engineer Boit as he tells us about the path when it comes to this journey, when it comes to embedded systems, what is there for us to learn, what are the areas that are available, what can we do with the skills that we gather, where can we find resources to learn these things, and generally the opportunities available as many of you want to know in this area. So Engineer Boit, I think it's now your time to talk. Welcome. Thank you for joining in.
Hello everyone. Can you hear me?
Yes, we can.
Okay, awesome. Thank you for having me. In case there's some audio maybe failing somewhere, please tell me. I'm trying to deal with them. I have a very interesting setup here, trying to get everything working, but I hope everything is all right.
Yeah.
Okay, thank you. So I hope everyone has had a good day, and I'm happy to be here, and I hope I will answer some of the questions that you've been asked, or maybe all of them. There's one which has come up a few times, and I think I'm very excited to get to that. Okay, so I'll go ahead and get directly to it. So I'll start by introducing myself. I think a few of you have interacted with, I think mostly on Twitter, and a few others on LinkedIn. So my name is Victor Boit. My background is electrical engineering. I studied electrical engineering at the University of Nairobi. Cleared a while back, Kitambo, 2017, there about. And then so currently I founded a company called Vina Robotics. So what we do at Vina Robotics is we are a hardware company in I think its most basic sense, where instead of, you see how we have software companies and people build software, then we are a hardware company. Our focus is from hardware, and then now the software implementation part of ours is majorly basically the firmware that accompanies these, and the web or platforms and such which accompany these solutions. So for example, if we're building an IoT solution, then we have IoT, right? We have the internet and the things. So we still have to build the internet part, the user interface. So that is why we have the other guys who handle the web applications now, building the websites and the platforms. So I studied, I think I mentioned where I studied, and so now there's I think the transition from studying electrical engineering to now embedded systems, where I can say that I'm an embedded systems engineer, not an electrical engineer, which is basically still an electrical engineer, but now this one is a bit more focused, if I could say that, or a bit more niche now. Part of the general umbrella would be electrical engineering. So so we started a lot of companies, I think, you start with one thing and then somehow you end up in a whole nother place eventually. So initially what we were doing is we started as we used to do the normal software. So we build mobile apps, we build websites, and I see how there is somebody who needs a website, we build a website for them. And then we started doing that for a while, from around, I think I incorporated the company while I was still in campus around 2016 thereabout. And then, so that's what we'd been doing. We hadn't done anything too specific. It's been just that web applications. And then there was a lot of mobile M-Pesa integration. There was this whole new adoption thing with M-Pesa integration into places. People wanted them in e-commerce websites, and then it was a very interesting, kind of knowledge to have at that time. So we did that for a while. So I think at the height of the pandemic, that was around 2020, around that was August thereabout. So I think that is when I remember, I used to do, I grew up with electronics a lot, and not and then now I was the kind of person who would open stuff. Unafungua hii, unafungua radio, you break it, you open this one. So now this was basically a passion that had been kind of forgotten in this whole hustle of after campus and trying to get things working, right? So I bought the kits. I bought the Arduino kit, the normal one, the one that is locally available, the Arduino kit, and then also the Raspberry Pi kit. So what I wanted to do was, I'd seen somebody online on YouTube. I used to watch a lot of those videos for people who are making the stuff. So this guy was making up an remote control airplane. So I wanted to make that. That was basically how it started. It didn't have anything to do with embedded system. It didn't have to do that. I think sometimes I speak to people, they tell me they wonder how that I've just been doing this for about 2 years, which is a bit interesting, because now from that it grew very naturally, kabisa, which was this thing which was born out of you just want to build this thing for fun, and then the other part is I was posting a few of the things that I was doing. So then one day, a friend of mine who they had a company, they were starting a company which were dealing with cold rooms, and then he was like, "Hey, by the way, I've seen you do these things, connecting stuff to the internet and all that. Can you build for us these sensor system which can connect is our system to online? And I know you did, because the company does software, so you can build for us like a web application that can also monitor that." So that is how I think we transitioned to it. So I did that one, and then I realized, okay, wow, this can actually, it actually has fit. It can take off. So basically now I did an entire rebrand of, I think that is when we moved from just Vino to Vino Robotics. But now in my head, I still had, I still wanted to do robotics, right? I wanted to build robots. That was where I set out from. But then now from there, you learn very fast how very unfeasible robotics can be, in not only in Kenya, but in like Africa, because we don't have, I think I can say we don't have enough problems that need robotics or something like that. But anyway, so we remained with the automation part. So it was the name Autobotics was a combination of automation and robotics. So we had Autobotics. So so I changed completely the company. We started move, did a full 180 to horizontal, a 90 to hardware specifically. So our core was hardware, and then now the things that were done that, and then from that first project, that is basically IoT. So now we specialize in IoT and now building the hardware. And now from that, we didn't want to build, what do you call them? We didn't want to just, buy and assemble Arduinos and all that, which was my biggest problem. I think by extension, what I'm doing, I think I've moved already from like our introduction. I'm almost now in the path. This is part of these I think conversation that we're having. So we let me just try to do a very smooth transition from that. So we're basically in that path section, right? So we started building that, and then it started as something now which we were building, these solutions. Now, especially myself, I was in charge of the hardware section. We still have small companies, so we don't have, like entire teams for this. But now everybody has their section that are taken care of. And today, since I think we're focusing on specifically embedded systems, let me focus specifically on that. So when I was building these were mostly lab prototypes, right? Which you take an Arduino kit, and of course, if you can use the Arduino Uno, then you use like the Pro Mini and the Nanos and Pro Micros and such. So we use that one from time to time, and then moving from that is you start feeling like there has to be a bit more that you can do with this. And you talk to a few people, and then a lot of them are telling you, we are building. We used to be domiciled at Gearbox around that time. So I used to work from the co-working space. So a lot of the other guys who were there, they would be building some projects with STMs and all that. But my thinking was, why do you need an STM? Because I was still very limited to the Arduino framework. Because I think the beauty of Arduino is that it's very documented and it's easy. And so it becomes easier for you to imagine that you can do anything with this. But then I think after a while, when you start needing a few more things, for example, one of the first times I think this one prompted was I was building this project which needed Wi-Fi, and I was using the ESP32 for that. So it was still I still no, this one is nothing which needed like a very custom PCB. It was just simply a proto board, and you put in the headers and you just solder a very simple setup, and then you put in the female connectors for the sensors to plug into the system. But now from these then there was a problem where sometimes you see how sometimes your phone doesn't connect to Wi-Fi for a while, and then when it doesn't, what you do is you turn off Wi-Fi and then you turn it on again, and then it connects, which is the typical hardware software issue about restarting something. But now the problem is Arduino couldn't provide that one, at least on the higher level that I was programming this with. So I was thinking of like, what is a solution I can do with it? And then now we got to another problem, which was the system sometimes just goes stuck at maybe a loop. And this was purely a hardware, maybe like a glitch or a bit flip or something just on that level. Now I can't fix this one because I don't know what it is. And then I don't know what time it happens. So that was, I think, the first time I learned about watchdog timers, where you have a timer which is basically measuring. You put it at the you have a timer run. It's like literally just a timer. It counts. You give it maybe a certain amount of time that is supposed to have been refreshed, right? So you will put this piece of code at the end of your function, so that if when it hits that code, we call it like kicking the dog. It's watchdog timer, or some being more gentle, you can say petting the dog. Where now instead of this dog is going to bite you, which is the symbolic of kicking the system into like a refresh, like a restarting or a reset, if it doesn't get pet. So that means if the program gets stuck somewhere along the way, that means the timer will run out before that section is hit. Then it will assume that something must have happened along the way, and then it resets the system. So that one was, I think, how I ended up like studying about RTOS. RTOS is real-time operating system. Now, see, you have Windows, right? And then you have Linux, you have iOS. So these ones are systems, these ones are operating systems which are designed to do things. That is why your app will hang for like a second when a phone call is coming in, because the phone call has a higher priority in your phone than the than your TikTok or your Instagram. So that is basically now what the OS basically handles, which is taking care of these things and shoving another one on the side, and then running these more important tasks, and then now bringing the other one when this happens. So when you have multiple applications which are running, then depending on whichever you are viewing at that point, and depending on like something like Truecaller with those things, it gets more priority of display more than another. But now when you're dealing with embedded systems, you're dealing with you're doing everything, right? And I think this is a good time now to define basically embedded systems. See, because so let me start with a simple one. We are building you're building a sensor system as a very simple one. You want this small piece of you want something to do a very basic function. For example, you want it to blink, right? For example, you want let's use an example. Let's say blink. Yeah. So for the simplest purpose would be to just blink a button, an LED. So, but now when you complicate it a bit further, between having a full operating system, like for a laptop or something like that, you have this very small complex system which needs to run a very simple function. For example, a fridge. You want this like a piece of computer, a piece of program, which is going to make sure that when the temperature of the fridge goes to 16 degrees or 10 degrees, then it turns on the fan. And then when it goes to 0 degrees or 5, then it turns it off. And at the same time, you need it to do the same thing, but for the freezer, you need it to be -5 and 5. So that when you can't have a very big system that is running that. You need a very small system whose simple purpose is basically that. So you not need a very multiple cores in a processor. You see how we have Core i7, which is maybe quad core or something like that. You need it to be much simpler. You need the purpose for it to be very specific. So I think the simplest thing I can say is when you're between a full-fledged operating system and a very simple function, which is that like dedicated, then that is basically like an embedded system. But now the embedded part means it's part like of a bigger solution, so that a computer is it's meant to perform multiple things. Okay, that doesn't quite fit in a very, but a computer has multiple purposes. I would say that. But now this one, you need it to be to run something. For example, a car's ECU, like but now not the entire ECU, but a very small microcontroller that runs the windows going up and going down. So it has, maybe assuming you have a very good car that senses the rain, and then it turns on the wipers and such. So that one would be, it's part like of a bigger system, but now you're building a very small section of it. So I think that is, the most general sense of like an embedded system, which I think the definition should be, the purpose is very specific and targeted. So that now when you come
could we
to
say,
yeah,
like for example, if it's a computer, since it has various like let's say systems within it, like let's say if it's something that's controlling sound, something else controlling something different, video, audio, are those things embedded? Are those by themselves embedded systems within the computer, or that's a different concept?
Ideally, yes. I think I think that would be like, basically a computer is like a collection of like embedded system, except now that for a computer, you don't have a specific microprocessor for audio, and then a specific microprocessor for this thing. I think what takes it away when we come to like this main processor, which is a single processor, big one, which handles everything now that way, where we don't have real-time dealings of stuff. Things are not happening at the same, like exactly. So the timing even, and I think the biggest difference between like a processor for that and the other one is that it's not, this other one is not, it's not, what is the term? It's even scheduling. Like I'd say scheduling of items, and then where it runs, it doesn't run exactly on like the bare metal. For example, you're not altering registers at the exact core of the system, but what you're doing is that you're dealing with these things at like at a higher level, so that the machine and the operating system sits between you and between your code and these lower level systems. So that now, for example, if you need the USB to work, you're not interacting directly with the USB. You're interacting with the provisioning of the USB by the operating system, which puts like several levels between you and that. But in the general sense, it's just that you don't have access to individual systems for individual purposes. You still have for this one merger, which runs basically everything. Even if you have a codec that is like an audio codec, it's still being provisioned by the main core, the main system, which becomes a bit different. So for embedded systems, you would, in a case is when you'd come to like an SoC. And I think if some of you know that, I'm guessing so, which is like a system on chip. Now you're still programming every single one of these things. It's just that they've put them for you into one system. But now you advance that kidogo, you go to a mobile phone, which is basically still a system on chip, but still kuna main processor ile unasikia Samsung, what is the name? Or they have these main processors. So they're not exactly that. So this one is just, I think it's about purpose specifically, if you're supposed to differentiate it from any other reason and something like that. And I think the most relatable thing which I would want, I think, us to know embedded systems from is like the normal house appliances, your TV, your fridge, your cooker, things like those ones, where these small control systems are built into it. Maybe you have an automatic door, maybe you have a gate, which is most of them are those ones. So so when you're building most of those, is there should carry on,
Yeah.
Okay. So I was I was talking about now when we're building these other system, which was, we needed a bit more control now in terms of how do we know where something is starting from and where it starts. How do you measure that this issue is happening and this other issue is more important than the same? Because eventually, for example, if I'm connecting two systems that are supposed to be communicating with each other, and this one is running, is checking the sensors, and then if it's checking the sensors and it's supposed to upload this data, but then another sensor fails, I need it not to upload this data before we get a very good a report from the other sensor. So if, for example, there was a sensor which kept a door sensor for this point, and then it kept falling like the other receiver. Some of the most simple door sensors are just basically a reed switch. A reed switch is this one which is switched by a magnetic field. So you have like a terminal which is made from like a different material. So one is magnetic and then the other terminal is like fixed. So if you bring a magnet close to it, then it's going to be attracted and then it's going to complete the circuit, and then basic analog, like how most sensors work, which is like triggering this thing to the other. So now I needed a situation where I can know when this sensor is not working, so that I either hesitate sending that or not. So I couldn't do that directly like that. So now you come to things like interrupt. You learn how do you interrupt a situation from that. So now, other than interrupting that, how do you make the system know that this one is more important? So now we get to like real-time operating system. And I think I want you to remember that the RTOS. So RTOS is now it's like a framework that has been made for. It's actually a framework. It's even referred to as a framework. So real-time operating system handles for you a lot of the things which you don't have to code them yourself manually, and it helps in like provisioning for most of those things, so that you don't even have these very low level kind of dealings with your hardware. So a very popular version is called FreeRTOS. You can start, but it's in the path of embedded system. That is just as soon as you finish with the Arduinos, and then you go to the ESPs, and then you're trying to do now complicate things a bit further, which is ideally how it should be done. So from there we moved from basically just doing those ones, and then moving to a bit more modifying libraries now, which is I think the interesting part in a lot of these embedded systems, which is you want to there is that I2C library that is there, but you've always been using it by simply downloading it and saying hash include I2C .h. But now do you want to know maybe how the driver is written? Because basically libraries are basically drivers, sort of, because they help you interact with with the hardware at that level. And drivers basically is like basically the code that you're writing so that you can access this one. You can access registers and such. For example, the I2C library is something like the RS485, the one which is used with Modbus. So you're supposed to access some registers, and for example, if it's a device that it has registers that you're supposed to access, and then you see if this bit has been set, if this bit is not reset, you set this bit to this thing, and so that you can get this other information, or what do you send in so that you get this one out. So mostly libraries will, is it abstraction? They'll try to save you from that level. And then of course, now when you move from there, then you go to this other level where you're trying to now actually deal with the bare metal itself. You're trying to what we call bare metal programming, which is basically now that writing there, where you no longer have you don't have a library, but now you are basically writing one for yourself. So unaenda kwa data sheet. That is when you start, reading the data sheets and all that. Now, I think the main part, I think, of embedded systems, which is the hardware development, that's where you come into play. Now, after kuunda hizi vitu zote, you've been making them kwa breadboard and all that. So instead of using these, Raspberry Pi, using these Arduino Uno, there's that chip that is there. So you don't want to, for example, you're doing a low power system, which is ideally a lot of where there's a lot of focus in a embedded system, because you don't want your TV to be consuming power a lot when it's running, right? Because we are always trying to save power. You don't want your fridge to also do that. You don't want your microwave to use so much power to simply just show you a clock. You want it to save power. For example, you also want your washing machine to remember the washing cycle when that one was when power went out. So the yetu unaanza tena, now machine imepoteza stima, and then you have to start all over. And those are some of those features, and you've noticed this I think a lot when you're buying stuff, where you realize that there's features that there are these things, these very subtle features, which they're called features because they're improvements of the same. Your cooker is a bit more expensive if it has a flame sensor, right? So when you have a flame sensor, then this is something that will cost you an extra 10,000 or 15,000 on the cost of that. So now when you're designing, you want to design, you won't put like an entire Arduino Uno in your cooker to check if there's a flame and then to turn off the valve that is sending the gas. Well, you could. Yeah, I think I would actually encourage you to do that. But ideally, you would now want to, if you're going into production level of system, you would want to design like a PCB. So mostly now you decide to do PCB design. And I don't know how much I can speak on in terms of PCB design, because there isn't, it's a very, I think, hands-on practical thing, which you basically visualize what you have in the breadboard, and then you think about it in one board, a very simple single board, which has the microcontroller on top, and then now you start doing electronics. Now this is where I think the electronics background is very
Actually,
important because you have, yes,
considering the
yeah.
way we are really diverse, there are people who don't even know what breadboards are. Maybe you could start there, just telling us a bit about the whole what breadboards are, what Arduino is, and then why not Arduino when you want to place it now in production, and then now PCBs, what they are, just so that we can move together for those who've not heard of this before.
Yeah, okay. So no.
Kevin, you agree?
Kevin is agreeing, yeah. Okay, so I think we did a very big shift from firmware to hardware there. So anyway, on firmware there's quite a bit to learn, and I think to conclude maybe on firmware.
Yeah.
Okay, firmware is basically software, but software that runs on hardware. It's a very fancy term. We like using that so that we sound very
You
yeah.
sound
So
niche.
yes, always say firmware, never say software. Software ni ya kuunda website. Yeah.
Ow.
Okay. So firmware basically is what you're using to write this. So there is one you would write in, for example, the Arduino IDE. When you talk about Arduino, I think I'll mention that. So IDE is Mraju IDE, integrated development environment or developer environment. Yeah. So you'll move for that one. I think when you're beginning, you will start with the Arduino IDE. It's very sophisticated nowadays. The initial one was very simple. And Arduino, the framework itself is it's very nice. It protects you from so many things that can, bug you. So when you're starting on that, other than that, you're not doing very simply, just try to work with actually buy the kit. It's like, I think 5K, and it has all the sensors I think you need for a starter. And then in addition to that, you'd have, I think the Arduino itself is included, and then jumper wires, and then, said breadboard. And then from there you can move from the Arduino IDE. You're still writing, these Arduino code, which most of its extension is itakuwa.ino, which is for Arduino. But now from there, you'd want to improve to, like, as a learning path, yeah, you'd want to improve, which I'm assuming when you're learning a lot of things, you're basically trying to complicate anything as you move along. So make it a bit harder on yourself. Then you'd go to, like, move to Platform IO. It's called Platform IO. It's an extension that is built into, I think that it's also built into Visual Studio Code. So you can also do that. And then Platform IO now will give you an opportunity to write proper C++ code, which now wacha kutumia string, character arrays and all that. And then now from there, you can now, go further to QBID. Now, hardware. Let's go to hardware. I think I've seen somebody ask about, PCB design and all that. So for hardware, now this is a breadboard how do you describe breadboard? Breadboard is it's these okay, wow, guys. Yeah.
Kevin, what's a breadboard?
How do you put it in English?
Without visualizing it.
Can I
Somebody,
help?
Eliud.
Yes, please.
Yes, please.
Okay, breadboard is a prototyping board. Like you can put together circuits or electrical circuit or electronics parts without soldering them. So you just, if you are trying to plug in a diode and a resistor, you just plug them in and then you plug them out once you're done. There's no need for soldering.
Perfect, perfect, exactly. Because the main thing I think with that is that where you don't have to solder them, so that it's not permanent. You just, and then it has, these very good very well spaced holes, I think 2.54 millimeters old, which fit like if you're using a Pro Mini, it can fit very nicely in there. And then sasa the jumper wires, these are basically just wire una connect to this one, and then you put it into the female holes in the Arduino Uno, for example. Yeah. So that is a breadboard. So it's basically a prototyping board.
I've just remembered we have them here. I don't know if you're seeing.
Yeah. So that the white thing. And then now these two wires are what we call jumper wires or DuPont wires. And then yeah. So as you can see, this one, there is a microcontroller there which just fits very nicely in there. That means you can plug it out and then use any other one of those. So when you move from these, this one is good for prototyping. Utajua sensor, how it's working and such. And then now you move from that one, you go to how to develop maybe now how to put this one into like a board which you can solder. These ones are always coming in like a breadboard, I think. Yeah. So these ones are, there's the proto board also. I think you can also show that. So prototype boards, these ones are the ones which you can solder now. And when you're moving to, yeah, also those ones, I think they're also called strip board. Yeah. So these ones you can solder them. These ones you can, now after you move from the other one, you need something a bit more permanent. Then you can just do Vero board. Yes, these ones. So these ones are the ones now, when you move from the other one, you use these ones when you're trying to make something a bit more permanent. So they have solder pads, which you can, put in the sensors and then solder everything. I think this is the soldering thing. The second image, I think, shows what we mean by soldering. So solder is just, I think, a very
Kuchomelea, but
low.
then
Yes, exactly. That is the term. Basically kuchomelea, actually. So you have that one to connect those ones. So now moving from this one to, yes?
No, so electronics people like fancy names.
Oh, yeah. You
Soldering.
have to use the fancy name.
Yeah.
Always remember that, guys. Eh? Yeah. So anyway, yeah. So you move from these ones, I think, to now where you want it to be something more neat. You need like a PCB. You see like these ones on the right, like right next to this one, something like that. So when you're designing this one, and you're trying to do like now these I think what you can see these PCBs and all that. So this one you're trying to move from this breadboard where you had jumper wires. Now instead of having jumper wires, you have strips of actual connecting wire that is moving from like every single one of those connections. For example, these holes is connected to another one. Then you would have what we'd call basically electrical connection. You have some sort of a wire, but now originally this PCB thing, the green one is like a copper. It's copper clad, right? So you're trying to cut paths on them and then disconnecting everything and then connecting every single connection that you would want for the individual paths, right? For example, if the wire was moving from like the pin number 5 in the microcontroller to the positive pin of like a resistor, then you're going to draw that. Now this is where PCB design comes in. And a common tool for that one, I think somebody had asked, was KiCad. KiCad is I think it's the simplest tool I can say would be good for this. There is the advanced ones, which is Altium, but now Altium will cost you $10,000, and I think well, I don't have $10,000 to spend on that. But if you can afford it, then well and good. But the KiCad, even especially in the version that is already currently available, current version that is version 7, it's it can solve for you, I think, everything you would want to do with PCB design. Like compare like at this level in time before you advance to that level where you need some of the features that are consistent in Altium. And a very good, I think, teacher who really helped me while I was starting PCB design. You can go to YouTube and it's called Philslab. I think Philslab. Philemon. So Philslab. Philslab, yeah. Yes, yeah. So Phil is very advanced on some things, but
in this video, I'd like to guide you through some of the key.
Yeah. So in some of the initial, he has others. You can see, like, for example, this one is very advanced. Yeah. But the initial one, he has some which are basic ones where you can learn now, for example, from KiCad, how to build a very simple system. Use that one. And then there is another gentleman called Robert Feranek, I think. Robert and then Feranek, Feranek. Yes, that first one. Now that one is also is that teacher who would teach you basically everything
we are doing
you need to
PCB
know.
layout.
Yeah. So he would tell you, I don't think there's anything you can't learn. Like after you have those two there, those are enough. Everybody else is good. And then I think one more person you should know on YouTube is workshop. What is the name? But okay, I'll remember his name and then I'll remind you guys. Now that one is the perfect teacher for Arduino. When
Are you
starting.
looking for drone bot?
Drone bot workshop. Yes, perfect.
Yes.
Thank you. Drone bot workshop. Yeah.
That.
Yes, I think. Yes, that one. Drone bot. Yeah. Yes, these gentlemen. Yes, that one.
Hello
So,
and welcome to
anything
the workshop.
Arduino. Now, anything Arduino that you would want to do, and it's not even limited to Arduino, but as you're starting Arduino, he will literally baby you through the entire, Arduino developing from the simplest, and he's a very good teacher. His lessons are quite long, but they are extremely detailed to the core. So you start with him, and then the other thing I think the most consoling part is that Arduino is everywhere, right? It's in terms of like resources to learn anything you'd want to learn in Arduino, then you would always find it there. So you can always start with that one. So you move from that one, I think from there, and I think I mentioned this one casually, but I want to reiterate it again. Get a course in electronics. Just get a course in electronics. Buy a book if you have to. I think what helped me was I had already studied it for a few years, but I still had to study. I even still have courses I'm still doing in electronics. This is from simply kujua, op amp in our kaje to voltage dividers to all that. When you're doing PCB design, these are things which determine if your LED is going to blink or not. And LED blinking is, I think, the hello world of hardware, because if it doesn't blink, it's actually the only reason you would most likely put an LED on your circuit, because that is how everything is healthy.
Yeah.
So electronics, you would need to know why you're using a certain capacitor, why you're using a certain resistor, and then even before you move to things which are a bit more advanced, for example, RF signals and impedance matching and things like parallel parallel what is it parallel sketches or something like that. So those are a bit more on the other end, but on the simplest, and I think this is something which is helping us, I think, at this point, is that there's a lot of adoption in terms of PCB design and all that. A lot of information is started to come in, and I think some of them you'll find that these are videos from like a year or two, some maybe about 5 years ago, because initially, in the previous years, these used to be very, I think I don't know if people are sitting on it or we just didn't have these platforms and people feeling like there's enough interest in this at this point. So there's not so much that I can say about like PCB design without making it sound very, very advanced to that level. Because I think when you start it, then it just starts moving along that, I think, that fast. But most importantly, just try to build it. I think Corsair, I think that is what I always encourage people. Just do something, let it not work this time, and then you would have learned a thing or two. Just make sure you figure out why it works. Now, sometimes you might not even, and then now do it again. I think from that practice, that is what it would make a difference. So move from that analog and digital design where you simulate. And if you can't afford that, there's a thing called Tinkercad. It's a whole website, I think. Tinkercad will help you to try out all of these things for Arduino without having to buy the kits and all that. And then it also gives you the sensors. And then I think the other most interesting section about Tinkercad is it also has 3D design. which I know it can sound like it's a whole nother thing, but now think about it. You've designed these, gate locking mechanism. You still have to package it, right? You still have to design a cover for that system. So you'd still need to have a bit of knowledge, move that design you've made in KiCad, the 3D design, and then move it to Fusion 360. And Fusion 360 is one of the best for that. So you'd use Fusion to learn now the 3D design, how to design something very simple. And then it has the free version, it has the student version, all that. Then just learn a very simple where how can you modify, how can you build a cover for maybe a Raspberry Pi. Then you transition from there now into when you design something which is a bit more complicated. So, and then of course you'll order the PCB. By that point, I think by the time you have a PCB that works, then you should be very good. And then I think in terms of the path that I would recommend in embedded system, I would still, if I were to start, you see how people say, if I were to do it again, I would do it differently. I don't think I would, because a lot of what helped, I think, with my path was that it was purely born out of out of a hobby. It was not pressured from, I need to learn this thing to know this thing. And that is why it has a very, very organic kind of a growth mechanism, where I stumble upon things, the need to build this after making a prototype and, having a few in the field. And then you realize, okay, this one doesn't really look good. We're a company now. We're supposed to be, giving out not prototypes per se, but we're supposed to be giving like official devices. And then we moved from there. So just start with the Arduino kit. After that, try to just make things a bit harder kidogo and look at a lot at what people are doing and compare that to that. And then I think at this point, there's a lot of people who are doing it locally. And I think I've spoken a lot. I think I'll let you guys ask a lot of questions on that. Then I think we can it will be easier to navigate over. Yeah. Thank you.
Thank you. So I think we'll now look at this questions and things people have pointed out. So let me start with what we had shared hapa kwa Kata was sharing my screen already. Yeah, on Mentimeter. And some of the things that have been pointed out were job opportunities. What are your thoughts on, are there job opportunities in embedded systems in Kenya? What are the types of jobs available?
Okay. So I think I'll color code them. I might say the color, wrong color somehow, but please. So I'll start with what is the, I don't know what is, there's the purple one which is said, what is the reg process? I don't know what you mean by that.
Regulation? Could someone, the person who wrote what is the reg process, would you please state it in full?
Hey, it's me. Let me smoke myself out. So I was asking, like, what's the registration process for low power engineers? Basically, because I do believe that there's some guys in the audience who are from like the engineering world, and especially the electrical guys. A lot of guys move to the high power. So we're just asking about like what's the market of the low power and the
okay, I think you're talking about I'm assuming registration or regulation.
The registration for IEBK and the rest of sort of the...
I think it's still covered under electrical engineering. So it's just simply that where you studied in Kenya, I think it's basically you have to study engineering, work under an engineer for a registered engineer for like 2 years. And then from there, they have an examination and something like that. Yeah. So I don't think they have something very niche specifically kwamba, you have to, be a like embedded systems engineer. No, like myself, I'm not, I use the title because I feel like I'm just, I know a few things, so it's a bit arrogant, I know, but it's not it's nothing official. So not official in terms of the. And this is, I think, what I need most of you to focus on just being good at what you can do. If you're good at what you can do, the titles and all that, they will come, and they shall. Yep. And then I think I hope that answers that. But a lot of that I haven't even registered with EBK even as a graduate engineer, so there's still that part. but you can do that. It's a good thing. So the other one is for low power engineers. I'm guessing it's job hunting for low power engineers. The one in brown, yeah, that one.
Yeah.
Okay, so low power. I think when you say low power, you're talking about electronics. Let me just talk about that, because there is electrical when you're talking about in terms of even when you are in your 5th year, you are doing either high current and light current. But now the other one, light current, is mostly limited to, they mostly talk about communication and that. But now let me say low power here, you're talking about electronics. When you're dealing with electronics, you're talking about things which operate between, I think, from around 5 volts, thereabout. So, and a lot of electronics do that. Even your processor, in your laptop processor, operates at around 1.6 volts thereabouts. So those are the electronic. So it's basically just that embedded systems. I think I'd cover that in when I talk about job opportunities in Kenya. Now, interestingly enough, when the Kenyan market, from what we've learned, I think from our experiences, it's very limited to IoT. Even the industrial IoT is still a bit ish, yeah. So this one is IoT, because where a lot of our clients are people in agriculture who are trying to automate something. A lot of people who are in like the industry. Now the industrial part is, and we've had like 1 or 2 clients just in that sector. These ones were, like the initial guys who had who needed to automate their cold rooms, and they needed like this entire solution. And the other ones, there's another gentleman, I think, who needed a controller for these city clocks. I don't know if you know them. You know them, you definitely do. The city clocks, but now they needed something which was automatic. So apparently now with city clocks, when power goes out, they'll just stop there and somebody has to come and reset them too. So they needed something which could fix this one. So those are some of them. So the challenge we have a lot with these, and that is why there are a bit fewer opportunities like locally, is that a lot of people still know that this is done abroad. Hardware is imported from China. Unataka sensor some light kwa nyumba or something, hiyo inatoka China, unanunua ludhuli, right? But now there are a lot of people who are starting to understand that we are doing this, and that it comes to marketing and all that. That is how we ended up having people building websites locally, because ukienda huko nyuma from around 2010, before just before WordPress blew up, we used to contract people to abroad. Companies that are Kenyan companies used to contract the Indians to do that. But now it's changing nowadays. So it's just that there is opportunities, but people don't know a lot about it yet. But now the interesting part is that it's very niche, and it's a very nice time for entry at this point. Yeah. Okay. So starting a business in Kenya, I think you'd basically do what we're doing. Start a business, focus on but now the difference is that for us it's general. We are doing it as a service. We are a service company. But you might decide to be a product company. For example, a very interesting one would be think about how many people have the automatic gates, zile za kufunguliwa na kadi. But most of them is just this entire solution which is brought in from China, right? You can decide to start building that. So that ninyi mna supply, you build these, automated systems for lock mechanisms and things like those ones. And then you move from that to, there are also guys who are doing automated gates. And a lot of these services that people offer as services, they're basically using devices which they are brought in. And most of the time it's not very customizable. So if you can build something and customize it, then you can have maybe a specific product that does this, or simply you are offering it as a service. Yeah. So it depends on where you're moving from that. But in terms of the job, and I think I can focus on that a bit, is there is a lot of opportunities in both freelance and abroad. Okay, I know I said abroad, it starts sounding very political, but you can there's a lot of opportunities for embedded systems engineer. And I want you to even try to look at it in not even simply even embedded systems engineers, or even embedded software engineers, especially embedded software. And this one you can work remotely, and they are bigger than software. And I think I can assure you that you can go to LinkedIn and try to look for embedded software engineers. And now the interesting thing about embedded software is you just need quite a bit, some knowledge in the actual, hardware development. A lot of your knowledge needs to be on the driver development, software, basically the firmware development. So Mejua, you're very good in C and C++, and you're very good in driver development. You're very good in RTOS. You're very good in the Linux kernel, and all those. So there's a lot of, like, really, trust me, there's more opportunities. Not more opportunities than software, but there's a lot of opportunities in that. So I don't want you to think about it in terms of Kenya or even like Africa. It's still catching on, but think about it in terms of like globally for the embedded software. And I'm telling you this from somebody who actually, hey, we get headhunted and what is it? Okay, now I'm biting my tongue. Headhunted, yes. On LinkedIn a lot on this, because somebody's there like, hey, are you interested in opportunities for this? Because now they can see that you can do that and the opportunities are there. So think about that a lot. And
the opportunities are both relocation and also remote opportunities.
Mostly for embedded software, the remote it's a very viable option. But now for hardware, it's mostly, I think, on site, because you can't, you're not going to debug a device which is used, for example. And the interesting thing is that these are not companies which are limited to things like IoT and things like that. A lot of these companies are like music companies. Some of the companies that approach you have companies which produce maybe, like music devices, either guitars or speakers. Unapata wengine, they produce maybe microwaves or things like those ones. But now they will always need engineers to build these things. So the opportunities are there. Yeah. I think salary bracket, well, abroad, it's a lot. Even locally, it's a lot. It's why even a small company like ours would not afford like a very, qualified embedded system engineer. And I'm not even kidding. Like, if I know a guy, like the guys I know locally who are doing it maybe for companies abroad, we can't afford them. We're not there yet. I think that should speak about exactly that. But now the other thing is why these guys are few is that it's very niche, and you have to learn a lot. You're not limited to one thing. You need to be basically a fully, fledged electrical engineer. You can design a circuit. And then in addition to that, debug this one, with an oscilloscope, with, a signal meaning and all that. And that is what makes you more, that. And then there's the other part, which is almost also very interesting, which is the UI design. You see how, for example, like the controls for a house or the controls from a device where we have the screen, you're designing those ones. So it's something I think a lot of people don't even know about, but there are people who specifically design UIs for these ones. And most of the time, these ones, I'll think about how we have people who do, is it Flutter, with the one which has a lot of very fancy, user interface. So you can design like those ones, but now for embedded systems. And now the interesting thing about embedded systems is that it needs to be small. So imagine designing something very nice, but very small. Yeah. So I don't know, is there anything else I missed?
Is Arduino good for job hunting?
Arduino is your, like, baby steps, your starting point for Nini. You cannot I wouldn't give you a job if all you know is Arduino. It's knowing how to read, but now you need to know more. What more do you know beyond that one? So so many to Arduino, and then you're like, now I'm good at HANA. You need to know how to work with. But now Arduino as a framework is still very wide, and it's quite big. And even people who write a lot of the code with Arduino, the industrial devices, are very good in like, advanced C and, libraries and building like very advanced systems. So I'm talking about Arduino here in terms of where when Arduino Uno and breadboard simply. So bare minimum, no.
Then there's a question here.
Oh, what's the bare minimum for deploying breadboard? I can't read that.
Is a variable solution good enough?
Breadboard. So yeah, okay. Look, recently, and I think that was less than a week ago. If somebody follows me anywhere, we delivered a project for some client which we literally used because they insisted that they have a very very short timeline and they just need something very immediate because somehow somebody else had most, and we couldn't have enough time to design the PCBs and other things from China. So we delivered it that way, and it works perfect. That is easy. So depending on the use case, well, it can work because most people actually, number one, other than not knowing how the nitty-gritties of this work, what a lot of clients care about is, does it work or not? Simply. So yeah, Isaac.
Okay, so I believe those are all the questions. Let me just check the chat. Yeah, I believe those are all the questions. Any last words?
Yeah.
Oh, there was this one, VLSI. Did you answer this? I don't even know what VLSI
Oh, yeah.
is.
So VLSI, I think VLSI is very large. It's very large scale integration, or in I think it's integration if I'm not wrong. But now VLSI is about I think CMOS. Let me just bring that up 1 second. Yeah, very large scale is integration, which is the process of creating an integrated circuit by combining millions or billions of MOS transistors into a single chip. This is, I think, in the more general sense how a lot of chips are made, right? But now VLSI is how do I say? It's very industrially thing where it's basically how chips are developed and made, which is not anything you need to worry about. It's like you worrying about how the engine is made. What your focus a lot should be on, like how to utilize a very tiny engine for a very tiny and specific purpose. So VLSI ni kama venye sensor imeundwa. You don't need to worry about how the sensor was made. What you need to worry about is how the sensor works. So the question was, what was the question about VLSI? Is VLSI necessary or something like that? Anyway, my point is VLSI is an industrial way of things being made. And I think that is how they've said anyway here. So VLSI began in the 1970s when most integrated circuit chips were developed and then widely adopted. You need the standard. It's simply how the chips were being made. Don't worry about that. It's not any, unless now, of course, you get to advance to that level where now you're trying to design. But now most of the time we don't try to do this because we can't do them. What we want to do is to use what we already have to do that. That's why we have, like the ARM Cortex and all that. It's like you are worrying about, the ARM Cortex or the Intel, core, how the Intel core is being made. It's basically that, I think. Yeah.
Okay.
Yeah. Anyway, so I think that is it, and I want to thank you a lot for that. And so what I would like to say for those people who are starting is start. If you're starting, you're really green. Start with Arduino. Just start with an Arduino and start studying electronics, and you will start seeing these. I think most importantly is how most people, even when people talk about coding, where they say, even if you're copying a code from somewhere, number one, most importantly, don't copy paste. They try to type the thing, and in addition to that, try to understand exactly why that line of code was done. Simply do that for this. Ukitumia sensor fulani uplug it hivi uweke this one to this pin and not the other pin. Try to understand why that was not the case. Ukiambiwa tumia drop out nini resistor, then across alongside an LED, then at least understand why that is the case. So you do that, then you advance pole. Just give yourself time to do a lot of these things and study electronics. Just soma tu kabisa, ujue kwamba this one is working, this one is working this way. But most importantly, it's what I always preach, and I will say this as the last thing, is consistency. Kabisa. Consistency. And this is, we've been getting told this since high school. Consistency is key, and I know a lot of you. But really internalize that and realize that you do something long enough, you will always make it. You'll always, succeed in it. And that is the thing. So that consistency. Don't do something kidogo leo unawachana nayo because it's frustrating, and you will always be good. Yeah. Thank you so much and for having me. And if you have any questions, by the way, I'm always on the socials. Just DM ulize swali hapa.
Please leave
and
your social links.
Oh yeah, so Twitter. I think that is Twitter. Is it Twitter? Yeah. And then LinkedIn is just Victor Boit. I don't think there is any other any. That one is mine on Twitter. Yeah.
Thank you, Ashley. She says, wow, what an amazing session. So thank you, Victor Boit, for coming through. I really hope that this session was helpful for everyone who had stayed till the end. And I'm very excited because I've also learned one or two things here and there. And I think what we take is, let's be consistent. If you want to learn, start with Arduino. The process is Arduino or the basics, and then now move on to soldering on Vero boards. And then from Vero boards, you can go to make PCBs and sell your solutions, or do freelancing, or what else? Freelancing, sell solutions, or get employed. Yes. So I really am eager to see what you guys want to do, whether it's employment, freelancing, or creating solutions. I really hope you want to create solutions though. Yeah, so I am Doreen Shemueno, co-founder and COO at Tenam Minds Limited. And TechTenam is an education platform whereby we train on electronics and web development currently. We also offer learning kits as a solution. So as you've seen there, Victor Kikorir was showing his kits. Yeah, so we offer learning kits. We offer them for rental or for sell, but we prefer offering them for rental so that you can just use them as you learn. And then from there, since at times it's expensive, use them as you learn and then give them back once you're done. We also offer it as part of a learning platform ecosystem. So you can check it out at edu.techtenam.com if you would like to join in and learn with us. Yeah, so thank you so much, Victor, for this wonderful session. And maybe you can now say last words as we end, just to tell us goodbye.
Oh, okay. Okay, I think just keep building it. Try something. I think that is most important. I'd always say there's a lot of things we make assumptions on, and then we just leave them because we weren't exactly sure how maybe to begin. Just start with whatever it is that you're starting with. Try to do something. Don't be afraid of failing. I think simply that, and be consistent. And if you can always try to do that, then I figure there is nothing you would ever have a problem with, and that is most important. And take pride in what you do, which is most important. Usifanye kazi tu ile ya kufanya. And we have a lot of people who do things like those ones, and then now you look at them and then you start thinking maybe this is why things are not working, but you forget that there is a certain level of professionalism that is needed for you to get working and get things working. So just put in the work and be very consistent and be very intentional. This is, I think, one last thing. Don't have a very clear idea of exactly what you want to do with something, so that you are not just doing if you're just doing something with Arduino, you'll never do anything beyond that one. But think about where you want to build a system, maybe to do something. Maybe unataka ya kufungua gate ama kufanya nini. So think about that as your end goal. And then most of the time, everything else, even when it gets hard, it will always be a path to this very, very specific goal. And I know in all that, all the best, and success in all you're doing. Yeah.
Thank you. Okay. Have a good night, everyone. See you next week on Tuesday. Good night.
Good night.